Hello everyone, this is week 7 Wednesday and we have two questions to solve using integer programming, that is a relaxation of LP programming. So the first question is about Ghandi Clothing Company, and we need to figure out their maximum profit based on labor and coding constraints, um, how much money they make, and how much is their cost. They also have variable and fixed cost. So let's choose x1 to be the number of shirts produced, x2 to be the number of shorts produced. Oh, I forgot to put the word shirts. And x3 to be the number of pants produced. And of course, because we are doing IP programming, we would like xi, any of those, x1, x2, or x3, to be greater or equal to 0, but also to be an integer. We also have another type of variables that will show us if a machine was used or not for the fixed cost of $200 for the shirts, $150 for the shorts, and $100 for the pants. So we can denote this as a different variable because we just want to know if they were produced or not. And we can call this variable yi. So in this case, y1 would be note if there were produced any shirts at all, and it will equal to 1 in this case, and it will be 0 otherwise. So if we don't produce shirts, y1 would be 0 and we would not pay the $200 cost. Similarly, y2 would be equal to 1 if any shorts were produced, and again 0 otherwise. And for y3 would be the same thing but with pens. And because those are either 0 or 1, we can put down that bi is 0 or 1, or it is a binary variable. So let's find out what we're looking in the problem. We would like to maximize our profit, and we know that profit is equal to revenue minus the cost. So I'll first put down our revenue and cost functions. So revenue is any money that we make. So if the sales price for the shirts is $12, $8 for the shorts, and $15 for the pants, if we multiply each of those numbers by the number of shirts, shorts, and pants produced, we'll have how much money we are making. And of course, we have a cost, and we have two types of cost in this problem. We have the variable cost, $6 for shirts, 4 for shorts, and 8 for pants. So I'll just write this one down as 6 times x1 plus 4 times x2 plus 8 times x3. And we also have the fixed cost that for even if we produce one shirt, we still need to pay $200. So that would be 200 y1 plus 150 for the shorts, and then another 100 if we decide to produce pants. Okay, so we found out our profit function. This is the one that we would like to maximize, but now we need to see what our constraints are. And as we were reading through the question and as we were looking at the table, we see that we have constraint for labor, which is 3 for shirts, 2 for shorts, and 6 for pants. So we'll multiply those respectively to the numbers that are produced, and we have total of 150 hours of labor available. And the next constraint is about the quote. That's how much quote we use for each of them. So 4 for shirts, 3 for shorts, and 4 for pants. And we have total of 160 square yard of the quote. So those are our subject to constraints. And another thing that you might be asking yourself is, how are x1 and y1 related, or x2 and y2 related, or also x3 and y3 related? And we can take those out of the subject to constraints. So for example, if we say I'm paying for producing shirts, I might as well make the most profit out of it. How much is the amount of shirts that I can produce to justify paying for $200 just to produce shirts? So how we will do that is by finding the maximum number of shirts that we can produce, finding the maximum number of shorts that can be produced, and also finding the maximum number of pens that can be produced. So the easiest way to do that would be to multiply, to substitute zeros for all of the other variables. So in the first case, we're gonna have 3x1 less or equal to 150 and 4x1 less or equal to 160, which would give you a maximum constraint of 40 shirts. If we substitute everything 0 except for x2, we're gonna have 2 times x2 less or equal to 150 and 3 times x2 less or equal to 160, which will give you a constraint that we can produce no more than 53.3 shirts, which I'm just rounding to 53, shorts. And for the last one, if we just solve for x3 and everything else is 0, the maximum number of pants that can be produced would be 6 times x3 less or equal to 150 and 4 times x3 less or equal to 160. That will give you no more than 25 pants produced maximum. So having all this, we can go into Excel and use Excel Solver to give us the optimal solution that will give you the maximum profit. So I have created the table in Excel, and also I used, we usually do everything in rows, but I put them in columns so they're consistent with the way they were in the table. So as you can see, the different colors, I have labor, quote, sales price, variable cost, fixed cost, numbers produced, the manufacturing units, and the maximum production that we found out just now. I'm gonna find the profit based on our profit equation, and then I also have the subject to constraints and how much I have available of each labor in quote. So let's do the first constraint. We know that the number of shirts produced times the hours should be less or equal than 150. That's why we will take the number of shirts, some product of those, and the number of the hours. And we'll put it in the subject too. So here's the sum product function. And then on the first one, we're going to put the hours needed. We'll just highlight this column, put a comma, and highlight the second column, which is the number of each produced. We'll do exactly the same thing for the quote. So the sum product of how much quote we need for each of them, and the number of how much produced. And those need to be less or equal to 160. So right now, let's do the maximum produced number. Remember, we calculated that those would be 40 if we produced any shirts. So that's why that is 40 times machinery used, yes or no. So if we use the machine, we can produce maximum of 40 times 1, which is 40, or if we don't use it, we don't produce any, and the maximum number produced would be 0. The same thing, but with 55, because we find out that we can produce at most 53 pairs of shorts. So 53 times 1, or 53 times 0. And for this one, I just need to enter it. It will be 25. That's the maximum number of pens. And then if any were produced or not. So we'll have either 0 or 25. So now that all of this is set up, let's put in our profit function. And again, I'm doing it as a sum product. The first part would be the revenue, which would be the numbers produced times the sale price. And then I will subtract the cost, which would be the sum product of the variable cost with the numbers produced plus the sum product of the fixed cost and if the machinery was used or not. So if the machine was used, that would cost us. If not, that would be just a 0. So I'm just leaving it here for a minute so you guys can see which cells go where. And I'm gonna click on solver to see what our optimal solution would be. I'm just waiting on solver to show up. Okay, there it is. So we're trying to maximize our profit. So let's just click on the cell that has the profit in it, and we are already at maximizing. So now we're gonna select our changing variables, and that would be the number of shorts and pants produced, and the binary that says if the machine was used or not. So here I'm just gonna click on it so you can see the highlighted portion. Let's start adding our constraints. So the first constraint would be our labor constraint. Again, in the subject to highlighted in yellow, we had how much of labor we used, and that needs to be less or equal to 150. For the quote constraint, we do the same thing. We do the subject to for the quote less or equal to 160. Our next constraint would be with the variables. So let's just look into them. So we want to add the constraint that we cannot have more than the maximum number produced. So if we only have enough labor available and enough quote available to produce, let's say, 40 shirts, we cannot produce more than that, even if we want to. So that's what we are doing here. I'm just highlighting the whole column of maximum production to be greater or equal to the numbers that were actually produced. And because we are doing IP programming, we would like to make sure that we add a constraint that all of the number of items produced, which would be the whole column of H3 through H5, are integers because we're in integer programming, and also that all of our machinery used is binary, it's 0 or 1. And as I was playing with it yesterday, I've noticed that linear programming in the solver does not let us use binary, even though it has it as an option. So Dr. Rensko suggested instead so here's the binary, I can just select them to be integers and bound them by 1. So then the value can be either 0 or 1 because the binary function for some reason did not work. So that's why I'm going to have two constraints. The first would be those to be integer, and then for the second one, the same values to be less or equal to 1, which would ultimately make them binaries. Just spare me for a second while I type them in, and then I will get to the answer. Make sure that the unconstrained variables are not negative mark is checked. And I just wanted to show you something that I had a problem with yesterday. So right here, ignore the integer constraints. If this is checked, it will give me non-integer numbers, and I'll show you why this is bad, and you need to make sure if you do IP that this thing is unchecked. So I'll leave it checked as of right now. and I'll show you what it gave me and what I had problem with yesterday. So as you can see right now, it is giving me 0.67 and 0.52 for a binary value that needs to be 0 or 1, and that does not satisfy what we're trying to do. So that's why I would go back to solver and make sure that I take the check mark off from the integer constraint, and again make sure over here you click on simplex LP. So everything should be okay right now, and we should be getting our results any second. Okay, so we got results, and we have 25 pairs of pens would be the ultimate production goal, and it will give us a profit which is the maximum profit of 75. So let's go back to our paper and put the result in it. Okay, so again, our maximum profit is $75 when we produce only pens. We don't produce anything else, and we produce 25 of them. Okay, so this is our answer for the first question, and let's go and see our second question. So the second question is about recording company that is putting songs on a vinyl, and the vinyl has two sides. They have 8 available songs with lengths 8, 3, 5, 5, 9, 6, 7, and 12 minutes. Each side is no more than 30 minutes of playtime, and the company wants to make sure that there is a minimum difference between the two sides. So they don't want the one side to be full of songs and then you listen and half of the second side is empty. So going through this, again we are doing integer programming. We cannot record half a song on the vinyl. No customers gonna like this. So let's see how can we approach this problem. Excuse me. So I'm using a variable which would be a binary. Let's call it xi, and xi would denote if a song was recorded or not on site A. So if it was recorded, the value of xi would be 1, or if it was not, the value would be 0. So we have I being from 1 to 8 because we have 8 songs. And again, if it was not recorded, the value of each of those 8 xi's would be 0. And I'm doing the same thing for side B. Yi would be a binary equal to 1 if the song was recorded on side B, or 0 otherwise. And please note that the song can only be recorded on one side. So if we are adding two binary numbers, xi plus yi, the value should be 1. And that would denote that actually the song was recorded on either side. That would be used later when we put this into solver in Excel. So let's see what else we have about this problem. It says that it allows 30 minutes of recorded time on each side. So how can we denote how much recording time we have on each side? So the first song we know it's 8 minutes. So if it was recorded, that would be on side A, that would be A times x1. And then if we record the second song, that would be 3 times x2, and so on. So if we add the products of the length of the song with each binary, if it was recorded or not, we should get a value that's less or equal than 30. And spare me just for typing a little bit slower. And the same thing is going on side B. If we record on side B, we would have the same thing, but with our variables being y1, y2, y3, y4, y5, 6, 7, and 8. And again, both of those sides need to be less or equal to 30 minutes. So those would technically be our subject to constraints. And something that I have noticed yesterday while I was solving the problem is we want to minimize the difference between the two sides. However, Excel does not support absolute value function, so we don't know if side A is bigger than side B or the other way around, but we can assume that side A is bigger than side B, and then we can eliminate the use of the absolute value just because we cannot plug it into Excel solver, or we can just assume that side B is bigger than side A later after we get the result and just flip the songs to the different side, to the opposite side. So like I said, I'm just making an assumption that side A is longer than side B, and we're trying to minimize the difference between the two. So we don't use the absolute value in this case. So plugging this into Excel, just spare me for a second. I have already prepared the table. So as you can see, I have song length, side A, side B. Again, a binary that shows if the song was recorded or not. All of the green is the length of each individual song. The first blue row is side A, if the song was recorded or not. So this would have a value of 0 or 1. and the same for the second blue row, which is for the side B. And song is recorded or not is just the sum of the two binary values on the top of it. So 1 or 0, and the total needs to be equal to 1 if the song was recorded or not, regardless on which site it was. So I'm just gonna get this value there, and then I will drag it for all of the songs. So now, as you can see, for song 2 we are still adding the two binaries if the song was on side A or side B. And to find out the length on each side, we are selecting how long each song is and multiplying by the number of the song. So if song 8 was um, one was is 8 minutes, we are multiplying this by side 1 if it was on side 1, and we are doing the same thing for side B. So it's just the sum product of the length and if it was on the side or not, the binary. Okay, and our last thing would be to find the difference between the two sides. So I'll just get side A, which is J3 in our case, J4 minus J5. And now, using solver, we'll try to minimize the difference into the both sides. So again, we are using the cell, we are minimizing it. The variables would be all of the binaries if a song is on side A or side B. So I'm gonna select those two rows. Here how they are highlighted. And I will start to add our constraints. So our first constraint would be all of the variables for the song sides to be binary, but as you remember from last problem 1, that we couldn't do binary in one step. We needed to select them as integers and also select them as less or equal to 1. That's what I'm doing right now. So I'm doing both steps while I'm talking. So I select them to be integers and also to be less or equal to 1. Our next step would be the length of each side to be less than 30. So that was length A, and length B right now less or equal to 30. And we also wanted length A to be greater or equal to length of B. And let's solve that. So our solution is that on side A we have 28 songs, on side B we have 27 songs, and the difference is 1 minute. 28 minutes and 27 minutes, and the difference is 1 minute. We also can see that on side A we have 1, 2, 4, and 8 song, and on side B we have third, fifth, sixth and seventh song, and the songs were recorded once regardless of the side, just because our row 6 is all ones. So let's put this in our paper. So side A, again, total time was 28 minutes, song with the tracks 1, 2, 3, 4, and 7. Side B was 27 minutes with tracks 5, 6, and 8, and 1 minute of difference between the two sides. So that was it. Thank you, and enjoy the rest of your day.